is we're just going to start plugging in values. So when x is -2, which is everywhere along this area right here, well, dy dx will be 1 over -2, which is a -1/2. Ah, wrong button again. So for each of those spots right there, because the y value is not affecting it, the equation is just 1 over x, we're just going to draw a negative slope line at each of those spots. And I'm trying to make it look a little more horizontal rather than just kind of like another line, because it isn't only a -1/2. Because at the next spot, the next area, when x is -1, now the slope is -1. So it should look a little bit more negative, meaning the lines look a little more vertical versus what we just had. And you'll see it looks like that. Same thing on the other side, when x is a +2, slope is a +1/2, so we're just drawing a positive slope line, making it look a little flat simply because it's only a half. And then when x is +1, slope is just +1, so it's going to look a little more vertical than the previous one did. And then lastly, along the y-axis, well, along the y-axis, the x value is 0. And 1 divided by 0 is undefined. So there's no slope line to be made there. So it's just going to be stuck like that. And that finished product is what our slope field is going to be. Again, all we're doing is plugging in the corresponding x and y values into the equation. They give us 1 over x, finding a number, and just doing a basic sketch of what a linear line slope would look like with that value. Since there is only x's here, you'll find that along the vertical, the line is not changing vertically at all. So when x is -2, no matter it's here on the x-axis, or down below at -2, or up at +1, it's still the same line. And that's the same as you're going through it. Yes, the slope can be 0. Same as if it was, thank you. It's based on the equation. So if the equation was like dy dx equals x, then when x is 0, then the slope would be 0. And then you would just draw a horizontal line for a 0 slope. Again, just try and do your best to make sure that you're creating that like relative slant difference there. So you can see there is a difference in those slope lines. We're going from horizontal-ish with the -1/2 to more vertical with a -1. If the next one was like a slope of like -2, make it look even more vertical than the -1 did, and just kind of go from there. For the most part, these are not going to be very large like grids they're going to have you do. From my experience with the AP test, this is typically a free response question that they ask you to plot a sketch of the slope field. And when they're doing that, there's generally only about like 12 points or so that they want you to go through. And again, you're just doing the same thing, relative slope lines, positive, negative, one versus halves, things like that. Just make sure, again, if the slope is undefined, you're not drawing anything because there is no slope there. Dan, good morning. Only 16 minutes late. Let's try and be on time in the future, please. Okay, that's fine. Just if you're just for the future reference, Dan, if you are having some issues getting in or whatever, just send me a quick email letting me know. That way I know you're not just like, sleeping in kind of thing. You're fine. I'm not sure what the heck is going on with your profile picture, but you're fine. All right, good. As long as you also email, that's also the more important thing. Making sure Mr. Spiegel, Mr. Patton, and all them know that you're having issues. You're just sending me a quick email on that, just so that I know that you're having some difficulty as well. Yeah, Blackwell in the morning. I feel like because everyone's trying to sign in at once, it starts getting a little bogged down. Once you guys are signed in, you're pretty much signed in for the rest of the day, and it seems to calm itself down there. But yeah, no. Initially, it might have some issues. All right. So I still have six of you who haven't responded to what we have going on here. So again, Owen, Julian, John, Dan. Let's make sure we're responding to the poll saying you're okay with the material. All right. So take a look at example two. So now example two is based on just y. So that would tell us now if there was no x in the differential equation, then along it horizontally, there will be no change because the horizontal, all the y's are the same, whereas all the x's are going to be different values. And again, they're not affecting it. As with before, you could also see this written as dy prime equals y rather than dy dx. It's used interchangeably. It is the same thing. So same as before, we're going to start plugging in some values. So starting at the top, when y equals 2, the slope is just simply 2. So we're going to make it a more steep vertical line than we've done in the past. Again, it's not changing as we go along horizontally because all those y values are still 2's. It's just the x values now are not changing. Next level, we're using 1. So again, straightforward. We're just getting a 1. So it's still positive, so just make sure it looks a little flatter in comparison. Along the x-axis, the y value is 0. So this would be an example of a 0 slope. So a 0 slope is just horizontal lines. I'll do that in a different color so it's easier for you to see. Obviously, if that's happening on an axis, just do the best you can to show the flat line. So for the most part, though, I wouldn't drive yourselves too nuts. They'll recognize that you're writing it as flat there rather than undefined because it's on a horizontal axis. You need to fill in all the dots. So everywhere on the x and y axis and all the dots in the different quadrants. So now the next line is at -1. So our slope is -1. Now it's a negatively sloped line. Try and make its like slant relatively similar to what you did for the positive one. And then finally, the last line, now y is -2, so the slope is -2. Again, make that look more vertical than what you just had. All right, so again, you're only filling the dots based on what they're giving you. And again, they're going to give you, like that right there is 25 dots. That's pretty much about the max they'll be giving you. Typically, like I said, it's about like 12 or maybe even 16 that you'd work through. But for the most part, it's relatively straightforward in terms of you're just plugging in numbers and getting a relative value. All right, so again, just respond to the poll, letting me know if you're having any issues with figuring out those different slopes. Again, there's no point at the 1.5, 0.5, -5, negative point. There's no dots here. There are only dots, the ones and stuff. So like if I wanted it at 0.5, there'd have to be a dot like right there like that. Without that, then we don't worry about the slopes. It's only symmetrical, Trevor, because of the fact that it's a straightforward equation, just y, and there's no combination of x and y in the problem, so everything looks very symmetric, very similar as you move horizontally or vertically. And again, this one, the slope is just based on the y value because the equation is just the y value. So part of Friday's lesson is going to be pretty much being given a slope field and kind of matching it up with a given differential equation. So part of how you're going to match it is kind of like how we just saw right here. As you look horizontally, nothing is changing on the horizontal. Therefore, that's differentials only has y's. Whereas the previous one, take a look at that real quick, nothing was changing vertically. That's based on there is only x's in the problem. So you can kind of use that to help match them up when you're doing that aspect of these kind of questions. All right, so let's take a look at now some more interesting ones. So now we have an equation involving both x and y. So in a case like this, again, we still got to fill in all the dots, but you can kind of pick and choose which ones you kind of want to work with. So for example, since it's x times y, well, whenever x is 0, meaning along the y-axis, the slope has to be 0. So we'll just do a bunch of horizontal lines on the y-axis. In addition, whenever y is 0, meaning the x-axis, we'll also have a slope of 0. So we can fill in all those horizontal lines because at any one of those points, slope is 0 based on, again, the fact that it's x times y. So if one of them is 0, the whole equation is 0. Now for the rest of it, well, it's going to entirely depend on us plugging in those numbers into the equation. So in this quadrant 1 area, we have the points 1, 1, 1, 2, 2, 1, and 2, 2. So we have to do those x times y's for each of those to find a slope. So we multiply each of those values. We're getting 1, 2, 2, and 4. So those are all positive values. So we have to make sure then they're looking, again, relatively more vertical versus the others for the ones that are like 2 and 4. So a slope of 1 is our usual, just nice linear slope. The slopes of 2 should be a bit more vertical looking. So we're going to make it look a little more vertical. And the slope of 4 is even more vertical. So it's going to look kind of like that. We then take a look at some of the other quadrants. So over in quadrant 2, we have a negative 1, 1, a negative 1, 2, negative 2, 1, and a negative 2, 2. So we'll find each of those slopes are going to be relatively the same. They're just going to be negatives. So negative 1, negative 2, negative 2, and negative 4. So same idea, only now it's a negatively sloped line. And then we just kind of fill in the rest of it. Going down in quadrant 3, we'll find those values are actually going to be the same as the quadrant 1s, because since they're products, since they're both negative, we're going to get back to the same positive slope. And then over down in quadrant 4, it'll be the same as the quadrant 2s, because now they're opposite signs again. So again, we have our negative 1, our negative 2s, and then our negative 4. Honestly, you can do it however you want it. I just broke it up like that so you can kind of see in this case, because they are products of each other, they're kind of all matching in terms of what the value is going to kind of get to be. That's really all I was going for that. Entirely up to you how you want to break it up. If you want to break it up at all, you can just pretty much just go starting at the top left, that's negative 2, 2, and just kind of work your way right, and then kind of go down, and just kind of keep on going like that. The key is you just have to fill in all the points. Once you fill in all the points, you've got the full slope field, and you're good to go. And again, as you can see, looking at this does not look perfect in any way. My ones don't all look exactly the same for each one. It just do your very best to kind of show that they are looking relatively similar to each other. Make sure, again, that if it's a more vertical slope, you're making it look more vertical versus another line. And obviously, anything that's horizontal, make sure it's a horizontal line. That one should be the easiest one to draw, with the exception of the undefined slope, because you're not drawing anything. All right. Anyone else? Any other issues with this? It should be relatively straightforward, correct? All right. So I want you guys to go ahead, give this one a shot on your own. Create your slope field. Again, however you want to go about doing it. If you want to kind of do it more systematically, doing the quadrants or the axes first, whatever you want, it's perfectly fine. But just start filling them in. I'll give you guys about 5 minutes, then I'll go through what my solution looks like. And then if we have time, we'll look at another one. If not, then, well, you've got the idea and we'll be done for today. But we'll see. So, again, I'm going to give you guys 5 minutes. Try it out. All right, just respond to the poll regarding whether or not you're ready for us to take a look at what example 4 is. Leroy, Pat, you guys still working? Okay. All right. So, first thing I noticed is that since we are dealing with y minus x, that tells me whenever x and y are the same number, that we have a horizontal slope. Because if x and y are both 1s, then the slope is 0. So what I'm going to do is everywhere that x and y have the same thing, we're going to do a nice horizontal line. Again, at the origin, kind of tough to see that, but it's right there. So that's the first thing I personally recognized. After that, I kind of recognized that, well, in addition to them being the same like that, in other spots, like when x right here is 0 and y is 1, the y is greater than it by 1, so it's a nice slope of positive 1, which will also occur here, and here, and here. Whereas on the opposite side, then it'd be a negative relationship when the x is greater than y by 1. So this would be a negative slope here, there, there, and there. And just kind of following that same pattern, as it turns out it really is a pattern for something like that. So we have a slope of 2 here. More vertical is 3 slope. And then a more vertical 4. And the same thing on the other side over here. We have a more vertical negative 2. A negative 3. And then a 4. So our slope field should look something like this. All right, so do we need to go through that in any way? Is everyone okay there? Okay, good. So again, something like this right here, we're just simply recognizing that it's a fraction. So we're noticing since we're dividing by y, anywhere y is 0, aka in this case the x-axis, we have an undefined slope. So we're not going to be doing any sort of slope lines on the x-axis because that's where y is 0. And then when x is 0, the numerator, we have nice horizontal lines. So we have horizontals here, here, and here. Again, nothing along the x-axis because at that point we have the slope of that is undefined. So now we're just going to fill in the rest of it. Again, using the same methods as before. So we're doing x divided by y. So 1 over 1 is 1. 1 over 2 is a half. 2 over 1 is 2. 2 over 2 is 1. And we kind of just continue following that pattern throughout the entire problem, getting lines to look like this. And then, again, continuing on. Because, again, the x and y's are pretty much the same there, so that's why they're going to be just sloped of 1. Whereas in other locations, depending on what's happening, you're having a more vertical or more horizontal connection. And there is some symmetry to all this. But again, it's fully dependent upon the equation you're getting, exactly how symmetric the total graph is supposed to look like. All right, so that's slope field, at least creating the graphs. Typically, it's going to be one question on a free response section, ask you to create the graph, because obviously you can't create it if it's multiple choice. And then from there, they'll ask you other questions regarding slope fields and differential equations, sometimes ask you to solve a differential equation, things we'll be discussing a little bit, or dealing with other aspects of what the unit here presents. All right, so that's all I have for you guys today. Couple things before you go ahead and sign out. Again, if you're doing the multiple choice section, I messaged the three of you independently regarding that. Make sure you check your email at 2:15 today for the password for the ExamSoft multiple choice. You have the 30 minutes for that, so make sure you're paying attention to the clock there. That's ExamSoft. That's going to boot you out. The FRQ for that, there's a bunch of you who owe me that. That's going to happen tomorrow. You'll get that email for that. It'll be posted on Blackboard, but we'll talk about that. Actually, I'll see you guys tomorrow. So just a reminder for that, for the, let's see, 1, 2, 3, 4, 8 of you doing the FRQ tomorrow. Again, make sure you're on Blackboard. 2:15 will appear, and then you're emailing me the PDF of that. Okay? The homework is due, Friday. It's going to be posted once class is over. All you're doing is just sketching slope fields. So that one I would probably recommend for, the printing out the worksheet and then kind of do it on there. No one missed the test yesterday. This is everyone. This is people who still had to make up the 7-1 to 7-4 quiz from a while back that we kept on getting pushed back with. All right, so again, for the 3 of you doing the multiple choice, that's today. For the 8 of you doing the free response, that's tomorrow. If you have any questions or concerns with that, please make sure you email me sometime. Give me reasonable time, but sometime before 2:15, or talk to me right now before signing out. All right, so that's it. If you're done, you can sign out. Hey guys, have a good one.